When you have a switch that you want to connect to a LAN, how are you going to connect it? You have to use some sort of media, and the most common LAN media is Ethernet. Ethernet is not just a type of cable or protocol, it's a network standard that the IEEE published, so you will often hear various Ethernet terms, such as Ethernet protocols, Ethernet cables, Ethernet ports, and Ethernet switches. So, what is Ethernet? It's basically a set of guidelines that enable different network components to work together. These guidelines also specify cabling and signaling at the physical and data link layers of the OSI model. For example, Ethernet standards recommend different types of cable and specify maximum segment lengths for each type. So let's take a look at some of the typical Ethernet media standards. The names of the standards specify the transmission speeds, the type of signaling, and the type of cabling. For example, in the standard name 10 base T, the 10 refers to transmission speed of 10 megabits per second. The word base refers to baseband signaling, which means that only Ethernet signals are carried on the medium, and the letter T represents twisted pair cabling. 1000 base SX and 1000 base LX are examples of optical fiber. You can also see that different standards have different maximum segment lengths and they use different connectors. You can carry Ethernet over different types of physical medium. Back in the days, coaxial cable was used, but today that's not the case. Twisted copper pair and fiber optics are much more popular, and not to mention a wireless option. Let's go ahead and take a look at copper media. You've most certainly already seen a UTP or unshielded twisted pair cable. Most Ethernet networks use UTP copper cabling for short and medium length distances because of its low cost when compared to fiber optic cables. Twisted pair cabling is a type of wiring in which two conductors, meaning the forward and return conductors of a single circuit, and these two conductors are twisted together, which eliminates electromagnetic interference from external sources. As you can see, a UTP cable is a 4-pair wire. Each of the 8 individual copper wires is covered with insulating material. Also, the wires in each pair are twisted around each other. A UTP cable is used in various types of networks, so you can imagine there are several categories of UTP cables, and those are categories 1 through 7. Category 1 is often used for telephone communications, but it's not suitable for data transmission. Category 2, on the other hand, is capable of transmitting data at speeds up to 4 megabits per second. Category 3 is used in 10 base T networks and can reach 10 megabits per second. Category 4 you'll see in token rings, with the transmitting speeds of up to 16 megabits per second. Category 5 is capable of transmitting data up to 100 megabits per second. Category 5E can go as high as 1000 megabits per second or 1 gig. Category 6 actually consists of 4 pairs of 24 gauge copper wire, which can transmit data speeds at up to 10 gigabits per second. Category 6A is used in networks running up to 10 gigabits per second, and the same goes for Category 7, and again up to 10 gigabits per second. As you can see, the higher the category, the higher the speed. Of course, the higher the category, the higher the price of the cable as well. Here you can see a UTP cable with an RJ45 connector and a jack. The RJ45 plug is the male component, which is crimped at the end of the cable, and the jack is a female component in the network device, and a wall or a patch panel. When choosing a UTP cable, you also have to determine whether you need straight-through UTP cable or a crossover UTP cable. To tell the difference in the two types of cabling, hold the ends of the cable next to each other with the connector side facing you. A cable is a straight-through cable if each of the 8 pins corresponds to the same pin on the opposite side. And it's a crossover cable if some of the wires on one end of the cable are crossed to a different pin on the other side of the cable, like we show here. Straight-through cables are primarily used for connecting unlike devices, whereas crossover cables connect like devices. And what does that mean? Well, if you want to connect a switch to a switch, you should use a crossover cable. But if you want to connect a switch to a router, you should use a straight-through cable. However, you don't have to worry about this much with most modern network devices. They automatically detect which cable connection type they need, and they have an appropriate connection configured. Another popular physical medium to carry Ethernet is optical fiber. An optical fiber is a flexible, transparent fiber made of very pure glass, actually not much larger than a human hair. This fiber acts as a waveguide or light pipe to transmit light between two ends of the fiber, so it's good for long distances and higher bandwidths. Now let's take a look at the construction of optical fiber. The two fundamental components that allow a fiber to confine light are the core and the cladding. Most of the light travels from the beginning to the end inside the core. In this example, the core diameter of 9 micrometers is very small if we compare it to the diameter of a human hair, which is about 50 micrometers. The outer diameter of the cladding is a standard size of 125 micrometers. And this standardization allows manufacturers to make connectors for all fiber optic cables. The third element here is the buffer or coating, which doesn't hold the light in the fiber. So what does it do? It actually is there to protect the glass from scratches and moisture. Be aware that fiber optic cable can be easily scratched and broken like a glass pane. If the fiber is scratched, the scratch could propagate and break the fiber. And don't forget, you need to keep the fiber dry. There are 2 fiber types, multi-mode or MMF and single mode or SMF. The biggest difference between them is the ability of the fiber to send light over a long distance at high bit rates. In general, I can say that multi-mode fiber is used for shorter distances at a lower bit rate than single mode fiber. For long distance communications, single mode is preferred, and in general, single mode is more expensive solution than multi-mode. The most significant physical difference is the size of the core. The core diameter can make major differences. And of course, you need to somehow terminate optical fiber, and that's where optical fiber connectors come in. And there's many of them out there. Today, there's roughly about 70 in use. Here you can see the most common types. So, what is the main difference? Well, the dimensions and methods of mechanical coupling. For example, the ST connector is usually used for patch panels, so is the FC connector, which is usually used by service providers. And you'll typically see SC and LC connectors as enterprise equipment.